Hello and welcome to the section on probability. This is great. There are two main divisions of probability that we're going to be talking about. The first one is theoretical. Theoretical probability is when you think through the problem. When you have a whole bunch of different outcomes and you count up how many, and you can do it all in your head or on paper. The other kind is called empirical. Empirical probability comes because you have actually run an experiment. It comes from data, what actually happened in the past. This happens from experiments. And this right here, you can kind of see, this will help you remember, empirical comes from experiments and theoretical comes from thinking about the problem of what should happen theoretically, and this will come from experiments. Let's first tackle theoretical probability. Let's start with like a bag of marbles. Probability, we have, let me see, 1, 2, 3, 4, 5, 6 green. And how many purples do I have? 1, 2, 3, 4 purples. How many reds? 1, 2, 3, 4, 5, 6, 7, 8. 8 reds and 1 blue. So if we add all those up, how many marbles do we have in the bag? 6 plus 4 is 10, plus 8 is 18, plus 1 is 19. There are 19 total in there. So if I were to say, what is the probability of reaching in there and picking out a purple? Probability of purple. I would say there are 4 possibilities. That's the part that I'm interested in, and I should put that up there, interested in right now. What are the probability of getting purple? There are 4 out of a total of 19. This is all the possibilities. Everything that's possible. Notice we don't have a possible of 21 or 22 different marbles in there. And that's it. We take 4 over 19. We can leave it as a fraction, 4/19, or turn that into a decimal, 4/19, and that gives us 0.211. This is about 0.211, which is 21.1%. You can list a probability as that, or that. All right, let's find the probability of red. What is the probability of drawing a red instead? Well, there are 8 in the part that we're interested in, so that is 8, and the total is 19. So part out of total will give us a probability. There's an 8 out of 19 chance that we'll do that. Plug it into our handy dandy calculator. 8 divided by 19, and we get 42.11. Alrighty, 42.1%. Or you could write it as 0.421. Notice that all of these numbers will always be between 0 and 1. Like on a quiz score, you can't ever have a probability being more than 1. You couldn't have like 22 out of 19 chances of getting a red or any particular color. And if you do it on the percents, it's always between 0 and 100%. That's kind of interesting to know. All right, let's see how that works with the die. If we say, what's the probability over here of rolling a 5? Yeah, rolling a 5. Well, we have a 1, 2, 3, 4, or 5, or 6. Those are the options. And so we have a total of 6 possibilities. And if we want to roll a 5, that's 1 out of the 6 options there. So it's 1/6. If we plug that into the calculator, we'll get 0.167 or 16.7% if we round there. Now, sometimes I'll ask a question, say, what is the probability of getting an even number? Yeah, what's the probability of getting an even number when I roll? Well, of 1, 2, 3, 4, 5, 6, notice there's 1, 2, 3 options that are even out of a total of 6 possibilities. That means, or 50%. Excellent. Sometimes it will ask something in kind of a tricky manner. They'll say, okay, we are going to reach into the bag and pull out, we end up pulling out a blue. What is the probability of pulling out a red? Oh, that's a good question. So they'll give you a stipulation here. If they pull out the blue one, that one's gone. So let's erase that guy from our ideal here. That guy's gone. And so now we have 18 options. So the probability of pulling out a red now, we have 8 out of a total of 18. And so it changes the probability. When you pull out the blue one, it changed how many totals there were in there. There could be a question like that. Let's plug that into the calculator and see what that looks like. 8 divided by 18, and that is 0.444 or 44.4%. Excellent. Since you guys are not here in class, we need to give you an opportunity to work through some of these problems on your own, so we'll send you to the boards virtually. To the boards! Okay, here are a couple of examples for you to try for yourself. Pause the video, do these problems, and then when you're done, go ahead and hit play. All right, welcome back. Example 1, let's go through these answers. If Jack has a bag containing a 1 white marble, okay, so there's 1 white, 6 red, so there are a total of 7. What is the probability Jack will pull out the white marble? There is 1 white marble out of 7 total. That's 1/7. Punch that into a calculator and you get 0.1428, I think. Move it 2 decimal places and we get a 14.28% probability. Number 2. What is the probability of rolling a 5 or a 6 on a fair 6-sided die? Well, there are 6 sides, so that's the total. A 5 or a 6, that's 1. 2 possibilities that we have. 2 possibilities out of 6. That reduces down to 1/3, which is 0.333. Move the decimal 2 places to turn it into a percent, and we get 33.3%. Excellent. Now, resetting the scenario, we're going to go down here and talk about connected events. So what happens when 2 things happen in a row? Okay, so for example, they would ask, of these 2 things, you have a bag of marbles and a dice. It would say, what is the probability of pulling out a purple and rolling a 2. So pulling out a purple, that one's not so bad. We know how to do that. Pulling out a purple is a 4 out of 19. So you have a 4 out of 19 chance of doing that one. And then we know rolling out a 2, we know that probability. That's there's 1 out of 6 options. So 2 is just one side, so it's a 1 out of 6. The question is, what do you do with these? And if these 2 things are independent of each other, then you times them. It's like you have a 4/19 chance here, and this one is a 1/6 chance, so it's like 1/6 of the time that you do this, you'll get both of them. So you times those 2 together. 4 times 1 is 4, and 19 times 6 is 114. So you're like, okay, we now have a 4 out of 114 chance of having both of those happen at the same time. 4 divided by 114, and we get 0.0351. Well, 0.035. If we round just right there at 3 decimal places, which is a 3.5% chance of both of them happening. So what will happen when you have these connected events is you will multiply them. And this could happen if you have decks of cards or flipping coins or any of those. Okay, here are a couple of examples for you to try for yourself. Pause the video, do these problems, and then when you're done, go ahead and hit play. All right, welcome back. Example 1, let's go through these answers. If Jack has a bag containing a 1 white marble, okay, so there's 1 white, 6 red, so there are a total of 7. What is the probability Jack will pull out the white marble? There is 1 white marble out of 7 total. That's 1/7. Punch that into a calculator and you get 0.1428, I think. Move it 2 decimal places and we get a 14.28% probability. Number 2. What is the probability of rolling a 5 or a 6 on a fair 6-sided die? Well, there are 6 sides, so that's the total. A 5 or a 6, that's 1. 2 possibilities that we have. 2 possibilities out of 6. That reduces down to 1/3, which is 0.333. Move the decimal 2 places to turn it into a percent, and we get 33.3%. Excellent. With that as a background, we jump back to the original screen where we saw that theoretical is thinking. And it's like, yeah, if you have a coin, what is the probability of getting heads? And you think through it. And it's like, oh, you have one possibility out of two. That's thinking through it. The empirical way of doing it, the second kind of probability we're going to go over, is what happened with an experiment. You say, I have a coin. Well, it may be one half, or it might be, what if it's weighted a certain way and always falls down? You actually flip the coin. So you flip it, and you flip it, say, 530 times. And of those 530 times, it actually comes up heads 410 times. And it surprises you, or you're expecting a half, you're thinking through it. But now, if they say, we actually conducted this experiment, what now is the probability of getting heads? And they'd write it like this, like a function. What's the probability of getting heads? You actually take the experiment numbers, 410 out of 530. And punch that into the calculator, and we get 0.774, or 77.4%. Yeah, and that's really all we're doing, is once you get the experiments, you take the data from the experiments and compute the probability without thinking. That's what we're doing here. We're not doing theoretical thinking stuff. We're doing experimental, get our hands dirty, get out and do an experiment and compute the data from there. So here's a problem for you to do on your own. Go ahead and work on this problem, pause the video, and then when you're done working on it, go ahead and press play in order to see the answer. Okay, welcome back. Jeff observed that his roommate washed dishes on 8 of the days of the last month, assuming there are 30, 31, and left them unwashed the other 23. Oh, look at that. That tells us there were 31 days in that month. Based on this data, and notice this is what makes it empirical probability. Based on this data, what is the probability that his roommate will wash the dishes tomorrow? Well, he washed them 8 out of the 31 days, and that's it. The 8 comes out of here. The total is the 8 and the 23 coming, goes on the bottom, and we punch that into the calculator and get 0.258. So he's washed them 25.8% of the time. That's our best guess for the probability that he'll do the dishes tomorrow. Great, that should give you enough to do your homework.